Hello there, it's KP the Math G. As you can see up here, KP the Math G. Well, I've been on a little bit of a trip for a couple of days. I had to go see my wonderful mom, and she's doing about as well as can be expected. So I'm glad to have gotten to see her. To the work that we need to do. We had done some derivatives, and we are through with those for right now. I say for right now because we're going to do one day, or maybe take a few of these videos, which right now this is my 40th video, but we're going to do videos down the road that have to do with some of those AP questions. If you're just a calculus student, you probably will not be doing any of worrying about this too much. But if you are a student, an AP calculus student, yes, you will be. And we'll look at some of that together, and there'll be some derivatives with the derivatives. So we need to get familiar with all of this, and that's what I'm here for, is to help you to become more and more familiar with everything. Alright, we are looking at, notice that we are looking at some trig functions, an e function, ln, and a to the x. That's what we want to look at, and maybe do, I've got 4, but let's see if we can do all 4. If not, we'll do just a few of these, at least a couple of them, of examples that involve these on the other side of the board. Okay, so let's go ahead and get started with the antiderivatives. Let's take a look at that. Okay, so first of all, the antiderivative of sine is, well, actually I have it, well, okay, is negative cosine of x plus c. And don't ever forget the plus c on the end. That's going to be important, because when we start looking at, this is called a general solution, okay? C could be 0, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3. It could be pi, it could be anything we want it to be. So this is a general solution, but we're going to later on look for a more specific or particular solution. Okay, to C, that's what we're looking for. Okay, later on. Alright, so notice that, you know, that when we took the derivative of so the antiderivative of sine is negative cosine. Okay. The antiderivative of cosine is sine. As you remember that the derivative of sine is cosine. Okay. All right. Secant squared. Secant squared is tangent. Tangent, not tangent squared, just tangent. Tangent x plus c. All right. Now, there's others that we don't have on here. For good reason, because they require greater in-depth, well, you have to learn how to find the antiderivative to these, and we left out on purpose secant by itself and cosecant by itself. We'll get to those another day. Let's put this equal sign over here. We're just not going to have room for it. The antiderivative of secant tangent, notice that secant is with tangent. Notice that every time secant, even secant squared, it's just tangent x plus c. Okay? And of course, if we took the derivative of tangent, we would get secant squared. Okay? If we took the derivative of sine, we would get cosine, and so on. Okay, so the antiderivative of secant tangent is just secant. Don't make this difficult. Secant tangent is just secant. Not secant tangent, it's just secant. Not just, just the first one. Secant tangent. Always put secant first. That's the same thing with cosecant cotangent, but this is negative cosecant. Okay. Notice that the C antiderivatives, the answers to any C antiderivative is a negative answer. Okay. Cosecant squared, well, that's going to be a negative cotangent. Let's put the plus C down here. Plus C. Alright, I'm running out of room here. Okay. Alright, this is probably the easiest one. The antiderivative of e to the x is just e to the x because the derivative of e to the x is e to the x. Of course, now plus c. This is delta x or dx over x. That's always ln. Not squared, not to some other exponent. The exponent is always going to be 1. Okay? Alright, ln of x, and sometimes they put the absolute values around the x because x is not negative. As a matter of fact, x cannot even be 0. It has to be greater than 0. Always positive for this here. Alright. The antiderivative of a to the x. Okay, so this is 1 over ln of a. Oops. Sorry. ln of a. And then times a to the x plus c. Alright. So before we flip the board over, let's go over these one more time because we're going to flip the board over. I have them right here. I can look at them. Antiderivative of sine, negative cosine. Antiderivative of cosine is sine. Secant squared, tangent. Okay? Secant tangent, secant. Cosecant cotangent, negative cosecant here. Okay? Secant squared, negative cotangent x. Okay? And I'm automatically saying plus c in my mind. E to the x plus c. This is always ln. Sometimes it's written as 1 over x dx. That's still the same answer here. Okay? That's still the same thing. Alright, so that's what that is. And then a to the x is 1 over ln a times a to the x plus c. Okay, so kind of keep that in mind. Those are very important that we remember. Well, let's face it, if you're in calculus, when you were in trigonometry, you had to remember a lot of things about sine, cosine, and tangent. You had to memorize identities. Memorize them. You may need to go back and still memorize identities. When we're dealing with these derivatives and antiderivatives, you're going to have to memorize them, especially if you're getting ready to take that AP calculus exam. You're going to have to commit these to memory. Okay? Alright, so we're going to flip it over. We might go back and forth from time to time, but let's look at this here. Alright, I have 4 examples, but will we have time for all 4 of them or not? I don't know, because my wife is cooking for me, and when she hollers, I'm going to go eat. So I don't know if she knows I'm videoing or not, so I'm letting her work in the kitchen right now. So, well, she likes doing that anyway. Alright, so now let's take a look at some examples. Bear with me just for a little bit. Let's see. Let's go with this one. Well, I like to use different colors from time to time, kind of change things up just a little bit. Look at this one right here. Let's find the antiderivative of 10 over, let's see, sine x, tangent x, dx. sometimes 10 dx will be side by side right here. One thing you can do, you can take this 10 out. There is a rule that if you have kx where k is a constant, you can take the k out and still have that right there. That's something you need to kind of keep in mind. Okay. Alright, so let's get started on this. And please bear with me. Let's take the 10 out for now. Alright, I'm going to put the 10 on the outside like this. And this is going to be 1 over sine x tan x. Oh, dx. Sometimes this will just be dx right here. But we'll just put it out here like this. Now, sometimes problems need to be rewritten. And we're going to rewrite this one. Okay, so let's see. The 1 can be over sine x times 1 over tan x, okay, dx. All this is 1, okay. 1 over sine is cosecant, isn't it? Oh, we got to know our identities, don't we? Cosecant. 1 over tangent is cotangent. Alright, that looks familiar. That's just equal to negative cosecant x plus c. Cosecant, cotangent is cosecant, but it's negative cosecant. Okay, so sometimes you have to learn how to divide this up, don't you? How to take the 10 out and then divide these up. 1 times 1 is still 1, isn't it? Okay. Oh, we did leave off something. My goodness. When you are integrating, you do not leave off the 10. So really and truly, this is incorrect. Wow, you don't take out 10 and not include it in your final answer. Now, there we go. And it was negative cosecant, so that's why I just put the negative in front of the 10. So negative 10 cosecant x plus c. Now it's correct, isn't it? Well, I can almost hear you shouting through, hey, what are you doing with the 10, Kp to math G? Yeah, sometimes I forget it too. Alright, there's that one problem. Alright, let's see if we can do another one real quickly. Alright, and once again, just to show you cosecant cotangent, the other side very quickly. There it is. Cosecant cotangent is negative cosecant x plus c. Okay. Alright, here we go. Let's do another one. Alright. Okay, let's do yet another one. Alright. Here's one. Alright, so here we go. This is going to be 8 sine x minus 12 sine x dx. Ooh, let me block that off. Alright, there is a rule that says that if you are integrating, let's say maybe something like this, I don't know, let's say in, oh, I don't know, I'm just trying to think of something, let's say minus just something, it doesn't matter, or n plus some k, alright, dn, then we can split it up, n dn minus n plus k dn, like that. we can split it up into two separate, okay, like that. Alright, K is a constant, alright. So, alright, here we go. Let's do this. Now remember, also, if we have a constant, we can put it on the outside, so let's go ahead and do that. Alright, cosine x dx minus sine antiderivative. Oh, let's put 12 out there in front. Okay, here we go, that's good. 12 now sine x dx. Simple as that, isn't it? What we have here is 8 times, now the antiderivative of cosine is sine. Okay, and I really and truly I don't need to block it off. Now minus 12, and remember that the antiderivative of sine is negative cosine x. Okay, let's see. A negative times a negative is a positive, so we can simply just say 8 sine x plus 12 cosine x. Let's see. Okay, there it is. And just going back, okay, just make sure you see that. The antiderivative of cosine is sine, but remember the antiderivative of sine is a negative cosine. Okay, and that's really what you're looking at there. Okay, and looking back again, antiderivative of sine is negative cosine, antiderivative of sine, cosine is sine. Alright, let's try to do another one yet, still, okay. Alright, I'm having fun, aren't you? I love this. And plus, these are fairly easy right now. They get harder. I hate to say harder. But, you know, I am KP to Math G. We can handle it. Well, actually, sometimes I have to study even the harder ones even the easier ones. I have to study and make sure everything is looking good. Okay, let's do good on these. Let's do maybe a couple more. Just to kind of give you an idea. Here we go. Here's the antiderivative of, that's a 9 there, over x. Okay, plus secant squared x. And it is dx like that. This is all one unit. Keep that in mind. You're integrating the whole thing. You must block it off or put it in parentheses or something. This can be rewritten as, okay, so 9 over x can be written as 9 times 1 over x. Right? Okay, so we could do that. And then, of course, if we're integrating 9 over x dx, then we can say, well, that's equal to 9 and 1 over x dx. Or we can even say 9, now dx is over 1, so that's just dx over x, like that. Okay, do you understand what's going on? This dx is in the numerator. I'm just putting it in the numerator. Alright, boy, that looks familiar, doesn't it? So that's that first part right there. We're going to say that already. This is going to be 9 dx over x. There it is. Okay, plus integrating secant squared x dx. Okay. Alright. Whoa. There we go. Now this thing is on wheels, as you can easily tell, and I have not locked the wheels in. I have to move it around, so I just don't lock the wheels down. Alright, well, we know what this is. 9 ln of x. And some people will say, oh, well, you got two things you're integrating. plus C1 or something maybe like that, and then plus secant squared. Okay, the antiderivative of secant squared is tangent, not tangent squared, just tangent. Tangent x plus C2. Alright, and some people do that because, hey, you integrated two things, and if you want to take that off, you can. Alright, like that. Look, well, let's leave it on for now. C1 plus C2 is just C. So a lot of times, some people do this. Don't do this. You don't have to. You don't need a C1 and a C2 here. Okay. And that was kind of like what I did on the last example. I just put a plus C on the end, so you can just simply do this. Okay. Okay. You don't need the plus C2. Just plus tangent x plus. Yeah, just do it that way. And actually, if we had done it the other way, we would have had 9 times C1, and still 9C1 is just all C. Just make it all C. Don't put a C1 and a C2. Okay. Maybe there are occasions when you have to. In this particular case, we just want it to be just that constant of integration at the end. That's all you have to do. Okay. Just one of them. Okay. Alright, so keep that in mind. So 9 ln, this is ln x right here. Okay. Secant squared is just tangent, and there you go. Alright. Let's look at one more. I think that should be, I'm just kind of giving you ideas of what this looks like right here. If you see that. Okay. I want to show you a little caution. Let's put a little caution here on the end. Caution. This dx over x squared is not equal to ln of x squared. Correct. See, you can rewrite this. That's a lot of times that's written like that. Just because it's that, it needs to just have an exponent of 1. Now that's ln of x plus c. Okay? Alright, and I should have put a plus c on the other, but this was incorrect. The first one was incorrect. This is actually, I can bring this up, and this is actually x to the negative 2 dx. Okay, and I'm not going to integrate that. I'm just showing you. Okay, so 1 over a to the n is a to the negative n, and that's what I did. I just brought that up in the numerator up here, and I put the dx beside that. Okay, be very cautious of that. Okay, some people miss that, and please do not do anything like that. Alright, let's move on. Alright, so let's throw in the whole 9 yards here. 5 to the x e to the x plus 4 over x. We've just done that 9 over x a while ago, didn't we? Ooh, that's ln, isn't it? Okay. Minus sine x dx. So I'm going to have 4 of these. Okay. So here we go. Let's do this. That's equal to 5 to the x dx. Okay. Minus integrate e to the x dx. Always put dx on the end. Okay, 4 over x dx minus integrate sine x dx, like that. Do it like that. Carry your sign, keep the sign on the outside. You don't have to put the sign inside of that. Just leave it like that. Leave the plus sign out here, or especially the minus signs. It's okay to do that. Okay? Now there are a few things we can do. We can rewrite. This 4 can go on the outside. So, alright, I'm just redoing one thing. Okay, we know what that antiderivative is. That's probably the simplest one. Now remember, this is for 1 over x, or just say dx over x. Okay, then minus sine x dx. Just remember, this is 1, and if you want to put it as 1 over x dx, you can, but that's still the same thing. Okay, that's still dx over x. This is the same exact thing. Okay. Alright, we know what this is. Now by this, I have to look it up again, but I'm going to try to do it without looking. I want to say this is going to be let me think about it. 1 over ln 5 times 5 to the x. Remember, at the end we'll put our dx at the end. Let me double check this. Yeah, got it. So on this one here, just put the base without the x here, and then the second time just write the same thing right here. I'm going to go into detail how to go about deriving that at this point. Just be content that we do it this way, okay? Alright, antiderivative of e to the x is just e to the x, so we have not done anything else there. This is ln, so this is plus 4 l times ln of x. Like that. Or you can just put the 4 beside there without the times signal, times sign. Alright, remember that the antiderivative of sine is negative cosine of x plus c, but now this is a minus a negative. What is that, y'all? Y'all know at this level that's plus, right? So let's see, we can rewrite this one more time. This is, remember, over 1, so we can just multiply numerator times numerator and denominator times denominator. So on this one here, it's simply just 5 over x over ln 5. Okay, minus e to the x plus 4 ln x. Okay, minus a negative is plus. I don't know if some professors will say, hey, don't worry about the absolute value bars. It does restrict that x, in this particular case, has to be greater than 0. Okay? Alright, plus cosine x plus c. Let me show you one thing here. Okay? ln, I don't know if you can see this or not, but I will bring it up where you can see it. Okay, let me clear all of this. ln of 1 is 0. Do you see that? ln of 1 is 0. But ln of 0, see what I just punched in? ln of 0. Okay, it should give me an error because it doesn't work. So when I hit it, I do get error. So that just tells me that ln has to be greater than 0. And one thing you need to look at and kind of get familiar with, I'm just going to put it in this little corner here, and I know it's real small, I hope you can see this, but ln never crosses into the negative x values at all. Okay, if anything, let me get another piece, okay, 1 is here, and ln does cross 1, and it just tapers off ever so slowly, but it does increase forever. But yeah, it's negative down here, but those are y values. It never goes into the domain, does not ever get into the x values. So it does help to see a graph of ln or e or whatever. E never ever gets negative. Never. Okay? So keep that in mind. I can put any x in for e, positive or negative, but I just cannot do that for ln. Okay? And so sometimes I say, oh, you don't need the absolute value bars because x has to be positive at all times. Well, and sometimes I say, yes, you do. So I'm going to leave them there until somebody tells me differently. Okay? So, all right, there it is right there. That was just an idea of what ln looks like, and it does help that you know what the graph looks like, so you'll understand why the absolute value bars are there. All right, well that's integrating this. Okay, we just integrated. Okay, all right. We didn't disintegrate, we integrated. Okay, don't melt on us, disintegrate and turn into powder. We got this. Because, by the way, KP the Math G is going to help you out. Okay, I'm going to help you through this. Okay, that's all that I have, and I'm really looking forward. This was the 40th lesson. I'm actually looking forward to the very next one where you have to find a particular solution